For question 2, you need to show that this equation can be reduced to 2 sine square theta minus 5 sine theta minus 3 equal to 0. So let's do this part here first. This means that you'll start with this equation and then you rearrange this until you get the second equation here. Originally, we have cotangent and cosecant. But in our final answer here, we only have sine theta only. So this means that try to change this in terms of sine theta and cos theta. Recall that cotangent theta is cos theta divided by sine theta. Here we have cotangent squared theta. Therefore, this is cosecant square theta divided by sine square theta. Next, we have cosecant theta. And we know that cosecant theta is 1 over sine theta. Therefore, this is 5 times 1 over sine theta, which is just 5 over sine theta. And then we have plus 1 equal to 0. Now, eliminate the denominators, which is sine squared theta and sine theta. So this is sine, this is also sine, except that this is to the power of 1, this is to the power of 2. So pick the highest power. So time everything here with sine squared theta. And we will get 3 cos squared theta plus 5 sin theta plus sine squared theta equal to 0. Now we can see that we have cos squared theta, sin theta and sine squared theta. So we will use the identity sine squared theta plus cos squared theta equal to 0. So do we need to change cos squared theta or sine squared theta? Look at your final answer. Final answer should only has sine theta only. Therefore, this one here should only has sine theta only, and hence we need to change cos squared theta in terms of sine squared theta. I did a small mistake there. It's supposed to be equal to 1. So cos squared theta is 1 minus sine squared theta. So now we just need to simplify everything. Negative 3 sine squared theta plus sine squared theta is negative 2 sine squared theta. 5 sine theta stands by itself, and we also have positive 3. But if we compare our answer with the final answer, they are not the same. Here we have negative 2 sine squared, but here we have positive 2 sine squared. So multiply everything here with negative 1. And now we can see that this answer is the same as the one in the question. So that's how you show that the first equation can be reduced to the second equation. And hence, we need to solve this equation for theta between 0 and 2 pi. Final answer should be left in radians since we have pi. Now, if you have the word hence, this means that you need to use your previous answer. And your previous answer is this one. So, we're going to be using this in order to solve for theta. A short reminder to students. For the first part here, you need to show that this equation can be reduced to this equation. Say that you start with your equation but you cannot show this final equation here. That is okay. If you cannot find your answer here, that's fine, because you can still use this answer given here in order to solve for theta. So just use the information given to you in order to solve for the second part. So let's do that now. Here we have 2 sine squared theta minus 5 sine theta minus 3 equal to 0. And here we have sine squared theta and sine theta. Therefore, this is a quadratic form and hence you need to factorize completely. Let m equal to sine theta. So this is m and this is m squared. By using factorization, you'll get 2m plus 1 times m minus 3 equal to 0. From this one, you'll get m equal to negative half. And from this one here, you'll get m equal to 3. And we know that m is sine theta. So that's how you'll get these two equations. Sine theta equal to negative half is a linear form, so we will apply Larka. For range, if you look at the question, theta is between 0 and 2 pi. Sorry, forgot about the equal sign here. So theta is between 0 and 2 pi. Using the linear form, we only need theta. And this is already the range of theta. So we'll continue with the quadrant. By looking at the linear form, you can see that sine is negative. Therefore, it should be in the third and the fourth quadrant. Now, theta is between 0 and 360 means that it goes anti-clockwise, starting from 0 until 360 degree. A is for answer. So here, the answer is for theta. So this is also theta. The first answer should be 180 plus alpha. And alpha is 30, therefore the first answer is 210. Continue until we reach the second one, which is here. And this is 360 minus alpha. And the answer is 330. And if you continue, you'll reach the end, which is 360, but there's no more answer here. So this means that we have two answers from the left hand side. But don't forget, final answer is in radian. And you'll get 7 over 6 pi and 11 over 6 pi. But don't forget about the other one, which is sine theta equal to 3. This is also in linear form, so we will apply Larka. Change theta to become alpha, and hence alpha is sine inverse 3, shift sine 3, and the answer is complex number. So for those who are using a grey calculator, you can see that you'll get a complex number since we have I. But for those who are using the black calculator, you'll see the word maths error. And both have the same meaning, which is alpha is undefined. So if you cannot find alpha, therefore you cannot solve for theta. This means that for the right hand side here, there is no answer for theta. And hence, there is only one answer, which is from the left hand side. And make sure your answers are in ascending order from the smallest value to the highest value.